Alright, so honestly, this is when these problems become a lot of fun. And that's because we have a bunch of points of intersection going on here. And notice, like this graph here, this is kind of just an example of what you might see. Notice for here, the blue graph is on the top, so you would do the blue minus the pink graph here. But then over here, it takes over to be the top. So this one will be the top one minus the blue one. So we'd have to split up our integral into two different intervals from a to b, the top minus the bottom. And then plus, we'd integrate from b to c. Let's just say that's a, that's b, and that's c. And then we would do the new top minus the bottom. So we're going to have to split up our integrals. It's just extra work, but the concept is pretty cool. So let's go ahead and take a look at this example. Right here, they're giving us two functions. We got fractions. I'll teach you how to get rid of those right now. And they're also giving us a left and a right bound. So just kind of get a brief little picture of what's going on here. Oops. So we have a left bound of -3, a right bound of 4. And they're giving us some sort of, graphs going through here. And then it looks like some sort of quadratic graph or something. Point is, we have a left bound, a right bound. We're going to find the points of intersection and figure out from there which one's the top, which one's the bottom, and how they split up. These graphs weren't too bad, just my blue one here. Let me fix that real quick, and then we'll move into it. So remember, these aren't the exact graphs, just kind of a general thing of what's going on here. So let's take the 1/2 x cubed minus 2x plus 3. Set it equal to the x squared plus 7 over 2x minus 3. So we're going to find the points of intersection here. Oops. All right. And so I'm going to multiply everything by 2 to get rid of that fraction. So we'll have x cubed minus 4x plus 6 equals 2x squared plus 7x minus 6. Let me double check that I have that all correct. All right, so let's go ahead and move things over. So we'll have x cubed minus 2x squared, and then minus 11x, and plus 12 equals 0. So now we need to figure out where the points of intersection are. So usually to solve these things, let me see. If you substitute 1. All right. So we're going to try to solve a cubic polynomial. Usually what we do is we try to figure out one of the roots, and they didn't give us one of the roots up front. But what we could do is usually 1 or -1 or 2 or -2 work. So let's try substituting in a 1 to see if that gives us a 0. If so, we can use that to find our other roots. So here I get 1 minus 2 minus 11 plus 12. And that's 1 minus 2 is -1 minus 11 plus 12. And guess what? That gives us 0. So that means that 1 is a solution. So that means that we could divide this polynomial we should be able to divide this by 1, or x minus 1. Because if 1 is a solution or a root, then that means x minus 1 is a factor. So division, we'll do synthetic division. It's the fastest. So 1 times 1 is 1, -1 times 1 is -1, -12 times 1, -12 gives us 0, is what we should have. So this will be x squared minus x minus 12. So essentially this polynomial here is the same thing as x minus 1 times x squared minus x minus 12. And of course we want to find out where it equals 0 at. So let's go ahead and factor that quadratic. So that would be x minus 4x plus 3. And so x equals 1, 4, and negative 3. I guess that he did give us two of the zeros because that's what the two bounds they gave us are at. So what we have is that our graphs are actually intersecting. They're actually intersecting there. They intersect at 1 somehow. Probably should have started with the quadratic. So we're intersecting here, and then at 1, and then back at this spot again. So something like that. So let's figure out, we're going to do a number line. This is where it gets a little more interesting. So we have negative 3, 1, and 4, and then we'll do f of x on the top, and g of x on the bottom. So let's start with a number between 1 and negative 3. I'm going to go with 0, so that's easy. F of 0 will equal 3. And g of 0 equals negative 3. And then let's go with something between 1 and 4. I'm going to use 2 because notice 2 cubed over 2, that's going to be divisible, get rid of our fraction. Same thing with the 2 is going to go away there. So g of 2 is going to be 1/2 times 2 cubed minus 2 times 2 plus 3, which is going to be 8 over 2 is 4 minus 4 plus 3. Oops, that wasn't g, that was f. If you can look at that time up there, it's 11:11. So shouldn't be filming this late. Keep making mistakes. All right, so we get 2 squared plus 7 over 2 times 2 minus 3. So that's going to be 4 plus 7 minus 3, which is 8. So here we see that g is actually the greater one. So there we go. So now we're going to split up our integral. So for our first one, we're going to do f minus g. And for the second one, we're going to do g minus f. So I'm just going to set it up. You guys can evaluate it if you want to. You should know how to by this time. So we're going to go from negative 3 to 1 is going to be f of x minus g of x. And then we're going to add to it, because we're just going to add the two areas together from 1 to 4. And this time g of x is the greater function, so it'll be g of x minus f of x. And hopefully that makes sense, because what we have is we have this area here from negative 3 to 1, where f is the greater one, and then we're going to just add this area here, which is that one, where our g of x is actually the greater function, so we want g of x to be ahead on that one.